In this video, we're going to be looking at 11.6, area of regular polygons. Now, in order to teach this most effective, I feel like we need to do an investigation so you can actually see where the formula for a regular polygon comes from and how it will be different for every regular polygon. So I have pictured here a regular pentagon. Now remember what regular means. Regular means everything is perfect, and it can be inscribed inside of a circle. So the perimeter is 40 inches. Find the area. So we do not have a formula for this pentagon. We have formulas for triangles and squares and rectangles, but we don't have formulas for pentagons or hexagons or octagons. So we have to come up with the process. So there is a formula, but before I tell you the formula, we're going to look to see how we can solve this problem. So the first thing we're going to do is we are going to put the center of the pentagon, and we need to realize since it is regular, we can inscribe it into a circle, and in that circle we have the center. So if I connect that right there, that little piece of the pie is a sector, just like this piece of the pie and this piece of the pie and this piece of the pie. So we actually have 5 sectors, but within the sectors we have 5 triangles. So now, the next thing we have to know is what is going on with these triangles. If I can find the area of one triangle, then I can find the area of the entire pentagon. So the first key pieces of information you need to know here is what degree is each of these angles here. So if it's 360 degrees and we have 5 equal sectors, then every angle here at the center is going to be a 72-degree angle. So what we're going to do is we are going to take out this one triangle, and all of the triangles are identical, and we know some information about it. So for example, if the perimeter is 40 inches, then that means the side is going to be 8 inches. So every time we have the tick mark there, that's 8 inches. Now, if we know that the bottom is 8 inches, and I drop an altitude from that, we know that's going to be perpendicular, we know this is congruent, and we know this is going to be 4 and 4 because it's going to bisect if that's the altitude. Now, it also bisects this angle here. So if this was 72 degrees, this is going to be 36 degrees. So in order to find the area of this triangle, we need to know this height, and I'm going to call it A. So the very first thing we need to do to find the area is we need to find A. So how can we find that A? We do not have enough information, but we have previous knowledge of trig ratios. 36 is nothing special. So in order to find A, I have a right triangle, I have opposite, and I have adjacent. So that is going to lead me to use the tangent ratio. So tangent 36 equals opposite over adjacent. So A is going to give me 4 divided by tangent 36 degrees. So again, we're going to turn to our calculator and we're going to say 4 divided by tangent 36. Again, make sure your calculator is in degree mode. And that is going to give me A is approximately 5.5 inches. So 5.5 inches. So now that we have that piece, we can now find the area of this pentagon. So this is what the area would be. So the area would simply be 5 triangles times 1/2 the base is 8, times the height was about 5.5. Okay, so let me close it like that. So the area is going to equal, I am going to do something here. I'm going to put 5 and 8 together for 40. And then we have a 1/2 floating here. And then we have a 5.5. Now there's a reason why I'm doing that. Okay, so I need you to notice some things here. So what exactly is the 40? Where did that 40 come from? Well, it came from the very original problem. That was the perimeter. Where did this 5.5 come from? It came from this A. You're going to learn that A has a special name. And then we have the 1/2. 1/2 is part of the formula. So if I now do this formula right here, we're going to have 40 times 1/2 times 5.5. And that is going to give me approximately 110 square inches. Okay? So now what we just did is we actually came up with a formula for a regular polygon. And this is the formula. The area of any regular polygon is 1/2 the perimeter times A. And A is going to be called the apothem. So if you look here, here is the 1/2. Perimeter, we got 40. And then the A is the 5.5. But in every problem, it is going to be different. So now let's go ahead and look at some definitions for this. So we have center of a polygon, radius of a polygon, the apothem of a polygon, and the central angle of a regular polygon. So here I already have it filled out. The center of a polygon is just the center of the circle, which I drew up here. The radius of the polygon is the radius of the circle, the circumscribed circle. Now, the apothem is where we really need to stop and talk about this. Apothem is going to be that lowercase a. That is the distance from the center to any side. The distance from any side. So here, this could be the apothem, or this could be the apothem. So for the pentagon, it's going to actually have 5 of those because it's the distance from the center to the side. Remember, the shortest distance to anything is going to be the perpendicular distance. Now, the central angle of the regular polygon is the angle formed by 2 radii drawn to consecutive vertices of the polygon. That's the sectors that I talked about. So that leads us to Theorem 1111, the area of a regular polygon. It says the area of an n-gon with side length s is half the product of the apothem times the perimeter. So area equals half PA. Sometimes it's written area equals half the number of sides like multiplied together, A. It's easier just to remember the perimeter. So now we need to talk about all of the different cases that can happen with a regular polygon. So please remember, all regular polygons can be inscribed in a circle. So for a triangle, you will have the center here. You will have 1, 2, 3 sectors. If there's 360 degrees in that circle, then each sector, which will make this angle, will be divided by 3. So this is going to be 120 degrees 3 times. But what you have to remember is when you drop this and it makes the apothem, it's going to split that 120 for a 60 and a 60. And that's going to be perpendicular. So in order to find the apothem of this triangle, you would not use a trig ratio because you have just created a 30, 60, 90 triangle. Now, the square, this is an easy one. You would have 1, 2, 3, 4, and you can see what angle they're making. It's 360 degrees divided by 4. So this is making a 90-degree angle. But if you drop the apothem here, that 90 is going to be split and you're going to be having a 45-45 degree triangle. So again, you would not use a trig ratio, you would use your 45-45-90 rules for that. So the pentagon we've already looked at, so I'm just going to go ahead and drop this. We're going to call that A, the apothem. This right here is going to be the radius. This is the side. This little segment right here, we saw that was S divided by 2. Our 8 became a 4. And then we called this in the pentagon 36 degrees because it was half of 72. So this one right here, you're going to have to do trig ratios. Now a hexagon, imagine again, you're going to have 6 of these triangles, but I'm just going to focus on this one. This is going to be A. This right here is your radius. This right here is your side. This is your side divided by 2. But what's happening with the angle? Well, it would be 360 divided by 6. So this big angle would be 60. But when you split it up here, that's 30-degree angle is now here. And now you would have a 30, 60, 90 again. Now, a heptagon, an octagon, the nonagon, and the decagon is all going to be behaving the same way. So basically you would take 360 divided by 7, then you would get that degree. But when you're doing your apothem, you're going to cut it in half again. So this one, this is a weird one, this would be 25.7. Now I'll show you how I came up with 25.7. 360 divided by 7, that would be the big sector, but divide that by 2 and you're going to get 25.7. Now I'm going to quickly do this for the octagon. So the octagon would be 360 divided by 8, but then you would have to divide it again. So this angle is going to be 22.5. The nonagon, the apothem angle would be 20 degrees. And then the decagon, if you drop the apothem here, that's going to be 18 degrees. Now, if you'll notice the 36, this one here, here, and here, those are all going to require a trig ratio for you to proceed with those. Okay, now I have moved over to the back, and this is the formula that I need you to be aware of. This is the area formula for a regular polygon. It is 1/2 times the perimeter times the apothem. Every problem will be different, so you just kind of figure out what you need to go and go from there. It says a wooden coaster is a regular octagon with 3 centimeter sides and a radius of about 3.92. What is the area of the coaster? So the first thing we're going to do is we're going to write down our formula. 1/2 the perimeter times the apothem. Well, we can see here if this is 3, we can quickly find that the perimeter is just 3 times 8 since it's an octagon. So that's going to be 24. Now the problem that we do not have the apothem. So the apothem is going to be this line right here. So it's going to be perpendicular. So we really need that A so we can put what we know in the formula. So I'm going to redraw that triangle and I'm going to label what we have. We know that the radius was 3.92. We dropped the apothem to a side of 3. So I know this is 1.5 and I know this is 1.5. But I really need to know this. So on this one, we can stay away from trig ratios because we actually have a hypotenuse and a leg. So we can just simply quickly do the Pythagorean theorem on this. So I've got 3.92 squared minus 1.5 squared. Square root that answer. And then I get the 3.62 for that apothem. So 3.62. And now I have everything I need to find the area of this wooden coaster. So area equals 1/2 times 24 times 3.62. The calculator will do that work for us. So 1/2 times 24 times 3.62. We're going to get the area of the wooden coaster is about 43.44 square centimeters. Okay, now number 2 is actually just seeing if you can read the angles. It says in the diagram, FGHJ is a square inscribed in circle K. Find the measure of, it's wanting us to find the measure of FKJ, so this one right here. And we should know Since it's inscribed, it's perfect. That is 1, 2, 3, 4 sectors. So the measure of FKJ is simply going to be 90 degrees because 360 degrees divided by 4. Then it's asking us to do KJF here. Well, if that's 90, and this is the apothem, that angle here is going to be 45, which forces this angle to be 45. So the measure of KJF also equals 45 degrees. Now, moving on to number 3, we have another pentagon problem. And since we've already done a pentagon problem, I'm actually just going to skip that one because I would like to move on and do the nonagon. We've not looked at a nonagon yet. It says a regular nonagon is inscribed in a circle with radius of 5 units. Find the perimeter and the area. So for this one, it's multiple steps. So the first thing I'm going to do is I'm going to redraw this triangle over here so I can find some information that I really need. I know this is a 5 and I know this is a 5. Now, since this is a nonagon, it has 5 sectors. Or not, 9 sectors. So 360 divided by 9. So this big angle is 40. But if I drop the apothem, which is also the altitude, it's going to split that to 20 because it's isosceles. So this is 20, this is 20, and this is going to be perpendicular. Now, I need to find the bottom on this one, and I need to find the apothem. So first, let's find A. I have a right triangle, I have a hypotenuse, and I have an adjacent. So that implies that I do cosine 20 degrees equals A over 5. So that's adjacent over hypotenuse. So A is going to equal 5 cosine 20 degrees. So A is going to be approximately 4.7. We're going to say 4.7. So that's the apothem. Now the next thing we need to find is X. Now in relationship to 20, that's opposite in the hypotenuse. So that is going to lead me to sine. Sine 20 degrees equals opposite over hypotenuse. So X is going to be 5 sine 20. So using the calculator again, 5 sine 20. X is going to be about 1.7, but that's just half of it. What I really need is I need to know how long this side is of the nonagon. So I'm going to multiply that by 2, and that is going to tell me my side is about 3.42. Now, next step, we need to find the perimeter and then the area. Well, now that we have the side at 3.42, I'm going to multiply that by 9. So the perimeter is 30.78. Well, now that I have the perimeter at 30.78, I can find the area because it's half times the perimeter times the apothem, which we have already found. So 0.5 times this answer times 4.7, and that is going to give me the area is approximately 72.3, and the units for this one is just units squared. So for this one, you just go through the process and using all of the knowledge that you've learned so far to complete that. Now that leads us to number 5. It says find the perimeter and the area of the equilateral triangle inscribed in F. So this one here is very similar to that last one, but now we're back to the triangle. And the triangle sometimes just makes life a little bit easier. So the first thing I'm going to do is I'm going to extract this one triangle right here. We know that's a 6, and we know that's a right angle. And remember, on this side over here, that's a 6. Now, this is the apothem here, and since this is inscribed, we have 3 sectors. Now, we've said that one big angle, this big angle here is 120 degrees. So that makes this angle 60 and this angle 30. So from here, we can actually use our 30-60 rules, or you can do trig. It's going to give you the same answer. But remember our rules. If the hypotenuse is 6, then the short side opposite of 30 is going to be half of that, and the long side is 3 square root 3. So that would make this one 3 square root 3. So now that we have this, if we add 3 square root 3 plus 3 square root 3, the side of our triangle is 6 square root 3. Therefore, the perimeter, if we have 1, 2, 3 of those, the perimeter is going to be 18 square root 3. Now, if you do the trig ratios, you're going to get decimals there. So it's actually kind of better to keep it exact for now. And then it says to find the area. So the area is half the perimeter times the apothem, which we found to be 3. So the area equals 1/2 times 18. So we can just go ahead and call that 9 if we want to. Just go ahead and get rid of the half. Call that 9 square root 3 times 3. So it looks like we're going to get 27 square root 3 square units. And that's when you would keep everything in exact. Now you can also do decimals, but sometimes exact is just easier. Now, very last thing here, it says finding lengths in a regular nonagon. So you need to either find the A, the R, and the S. So this is what you can use. You can use the Pythagorean theorem, you can use special right triangles, or you can use trigonometry. Always try to use the one that is easiest to make your life a little bit easy. But it would be beneficial to have a good calculator.